morning, good afternoon, good evening, and welcome to the latest edition of Q Talks, the online on demand series of conversations all around the future of water, powered by KTM. My name is Tom Freyberg. I'm an environmental journalist and content creator specializing in water, and I'll be your host for the next 30 minutes. Now, the topic today we're addressing is PFAS. Now, I'm sure most of you tuning in have heard of PFAS, have seen the headlines and the stories, but just thought I would give a bit of context and a sort of gentle reminder. So per and polyfluoroalkyl substances, PFAS, they're a group of man-made chemicals that includes PFOA, PFOS and GenX and many other chemicals. They've been manufactured and used in industries across the world since the 1940s, used in items such as non-stick frying pans to water-resistant clothing through to firefighting foam. Now, they're often referred to, and you may have seen this, as forever chemicals due to the fact they are extremely hard to break down. Now, PFAS contain multiple carbon fluoride bonds, some of the strongest chemical bonds in nature. They've been found in food packaging, commercial household products, workplaces, drinking water, and even living organisms such as fish. And as one consultant previously told me in another call, if you look for PFAS in the environment, you will find it. In fact, there have been known cases where they found PFAS even in Antarctica. So to talk about this further, I'm thrilled that we've brought together three very different but also complementary viewpoints in the panel today. We have a researcher, a water utility, and also the federal level protection agency. So I'm pleased to welcome to the panel, we have Jason Dadigas, who is the Executive Director of Water Quality and Technical Resources for Orange County Water District, known as OCWD from California. Jason, good to see you again. We have Roberta Hoffman-Karas, a senior scientist on the water treatment team from KWR Water Research Institute from the Netherlands, back here in Europe. Roberta, good to see you. Thanks for joining.
Thank you.
And last but no means least, Mohammed Ibrahim, who's an environmental engineer and group leader at the US Environmental Protection Agency, the EPA. Mohammed, great to see you.
Thanks, Tom.
So we want to kind of, I think, just get going by hearing from each of you as a way of an introduction to your kind of organization, the size, the scale, and really the meeting point or the interface with PFAS, whether you're a utility or a researcher looking into the latest developments, or Mohammed with the EPA on the roadmap side. So why don't we start with yourself, Jason, in terms of a bit of background on OCWD and how you're currently looking at PFAS as a challenge.
Yeah, thanks, Tom. Orange County Water District is a somewhat unique public agency here in Southern California. We are charged with sustainably managing our local groundwater basin that serves 2.5 million residents and currently makes up about 77% of the local water supply here. And our nexus with PFAS has really come in our groundwater basin. We manage it on behalf of 19 major retail agencies who have wells that pump from the basin. You can think of us kind of functionally as the groundwater wholesaler, if you will. And so in that role and working with our retail agency partners, we've unfortunately had PFAS impacts to their municipal water supply wells. Of the 19 major producers, we've had 11 of them have had to shut down one or more of their wells due to detections of PFAS above state advisory levels have been established by the state of California's Division of Drinking Water. And given the value of that local resource here, and even just some of the economic considerations of what alternative water supplies are, that's really driven us to put together a very large, rapid wellhead treatment program with those 11 impacted retailers, trying to restore groundwater pumping capacity from about 60 impacted wells over the course of the last 2 to 3 years. And so we're in the middle of that program now, trying to bring back that local water supply through treatment.
Very good. Thank you, Jason. And the agency has won awards for its work on kind of trialing different technologies and looking at granular activated carbon. So we'll come on to that in a bit more detail later on. Thanks for the intro. And Mohammed, tell us about your sort of role, the interface and the nexus with PFAS within the IPA for your day-to-day job.
Yep. Thanks again for the invitation. I work here at the Office of Research and Development, and research that I lead is focusing on development and evaluation of novel treatment technologies with specific focus on emerging contaminants, including PFAS and others. So just a quick disclaimer that the views expressed today are mine and do not necessarily reflect the opinion of the US EPA. With this, I just want to also advise everyone to check our EPA website. Like, we have amazing resources, and among them, that we have a full access to a document called like PFAS Strategic Roadmap. It's EPA commitment to action to 2021 to 2024. So in short, this document highlights the major parallel tracks that EPA's offices, regions are taking, like, in order to tackle the PFAS pollution. The roadmap discuss 3 goals, which we can call like the 3 R's, like research, restrict, and remediate. For the research, EPA invests in research and development and innovation to increase the understanding of PFAS exposure and toxicities, human health and ecological effects, and effective interventions that incorporate the best available science. The second goal is restrict, and this is done by a comprehensive approach to proactively prevent PFAS from entering air, water, and land from the first place, so that they don't reach any way to concentrations that can adversely impact human health and the environment. Lastly is remediate, and this is done by broadening and accelerating cleanup activities. For example, we encourage and maximize responsible party performance and funding for investigations and cleanup of PFAS contaminations. So where are we now? For us, PFAS is among the top priorities for the agency. A lot of collaborative activities among our offices, regions are either ongoing or in the planning phase to meet the timeline that it is listed in the roadmap. For instance, the proposed PFAS concentrations for drinking water regulations are expected to be shared very soon, which is a very, very big step. We are all looking forward to it. My research, for example, also cover a unique aspect of remediation. I manage multiple projects that target hard-to-treat waste streams, like RO retentate, regeneration solution from ion exchange resins, and others. And these projects aim at both separation and destruction of PFAS to limit their release to the environment.
Thanks, Mohammed. Interesting to hear about the roadmap, and we'll come into some more details later on the kind of coupling of technologies that you mentioned as well. So great stuff. Roberta, back over the Atlantic into the Netherlands, here in Europe. Tell us about your kind of role within KWR's drinking water team, and also the interface with PFAS as well, please.
Yeah. Well, thank you for inviting me, Tom. I work at KWR Water Research Institute in the Netherlands. This is an institute that covers all fields in the water cycle. I myself am in the team of water treatment and resource recovery. Well, PFAS is not a resource we would like to recover, but water treatment certainly is a very important topic within our research institute. But also analytical department is involved to improve analytics, to be able to measure the very low concentrations that now may become standards. Mm-hmm. And we also do research for the Netherlands, but also for other countries, to measure the concentrations of different PFAS in surface water, groundwater, wastewater, drinking water, and also how to treat water to remove PFAS. And as Mohammed already mentioned, you can look at removal or destruction. I'm involved in both types of research. So in adsorption processes, a colleague of mine is involved in membrane processes like reverse osmosis. And oxidation doesn't work for PFAS, so we are also investigating advanced reduction processes.
Very good. And I think that that global reach from KWR is very important here, because a lot of the findings and the collaborations and partnerships that you have already to kind of bring this into them is going to be really important moving forward. Good stuff. All right. Thank you, Jason, Mohammed, and Roberta. So I want to touch back on that roadmap that you mentioned, Mohammed, because you said, I guess one of the things coming up shortly is actually the PFAS limits, the concentrations, the data that's going to come up. What's the sort of time frame on that we're expecting?
Okay, expectations. I when I said very soon, it's literally soon. I believe we are expecting it early 2023. So it's just like you release the numbers and then you get feedback and a lot of discussions before releasing the final regulations. So there will be a big splash, I guess, with that. It's like adding it to the Clean Water Act is not something that you have as an activity every day. So it will impact a lot of activities in the water industry, I believe, which is a long-awaited action, in my opinion.
Mm-hmm. Yeah, amending existing regulation is not an overnight process. I think we can all speak on that. But also, so this, for the wider audience, this is stating the level of PFAS in following water that's been treated, correct? Right?
Yes. So you have to set limits for hazardous chemicals in order to indicate it as a safe for certain purpose. It can be for drinking, it can be for irrigation. And what we are talking about here is mainly for drinking water purposes.
Okay, so lots of, I think the global eyes and ears of the world are going to be looking at those standards. Jason, then, from your point of view, from Orange County, obviously you're being seen as one of the more progressive utilities, especially in this area. So how are you sort of anticipating the standards that are coming from the EPA next year?
Yes, Tom, we're certainly eagerly awaiting those. As I mentioned, we've largely been governed to date by state level advisories for PFAS contaminants, and so yes, we're very interested in what types of regulations EPA decides to formalize on drinking water with the actions that Mohammed has described. I think we're hearing and EPA has discussed publicly that as they went into this, they were considering sort of conventional sort of contaminant by contaminant numeric limits, or perhaps something a little bit different to try to, capture the PFAS family, or at least more members of it more broadly, and perhaps suggesting a slightly more complex, different regulatory framework that maybe isn't typically applied to chemical contaminants, at least in the U.S. And so I think we're interested to see where EPA comes down on that, and certainly our hope is, the investments we've made in treatment to date and are planning to make will be compatible, right, with those regulations. Mm-hmm. In the U.S., the way it works is when if there's a difference between state and federal regulations for a particular contaminant, essentially that comes down to essentially almost a negotiation or discussion between the states and EPA about ensuring that the state standard is at least as stringent as EPA's standard. And so if there's any difference in that is something that'll have to be worked out. And here in California, our regulators are on their own timeline to set an enforceable standard that right now looks like it's roughly maybe running a couple years behind federal EPA. So it'll be interesting to see what the state of California regulators do when they get a chance to see EPA's proposed rule for drinking water, and how close they decide to stick to that, or does California decided to perhaps go a different way as well.
Very good. Thanks, Jason. Yeah, and interesting to see the dynamics, I guess, between the state and the federal standards and how they're connected. But Roberta, presumably this is something that kind of the KWR and the Netherlands are keeping an eye on as well, right? In terms of the EPA standards that are due to come out, and also looking at the current standards and limits within the Netherlands.
Yes, of course. And we know that also the EU is working on standards, and in that respect, the Netherlands too will be adopting standards also very soon, I expect. And that poses a lot of challenges, because what we now know is that the standards will probably be in the nanograms per liter region. And that causes a lot of challenges for water treatment. It's in the several surface waters, for example, concentrations are significantly higher already.
Mm-hmm. So to actually meet the nanogram per liter, you're looking at significant upgrade investment to the existing infrastructure to get down to that level, right?
Yes, I think it will be necessary in many places. Yes.
Okay, so let's because I don't want I'm very conscious that when it comes to standards regulation, you can go down that wormhole for the duration of the Q talks, but we want to kind of keep it focused on the solutions and the innovation that we're seeing and link in towards the digital as well. So, Jason, why don't we start with you then in terms of what Orange County has done so far with some of those actually treating the PFAS in the water. We've spoken before on the use of granular activated carbon and kind of an award-winning pilot scheme you've done. Can you give us an update on kind of some of the results that you've seen from that and anything you can share from the technology solution that you used?
Sure. Yeah. Given that the size and scope of the capital investments we've had to make to restore local groundwater, currently our capital program is estimated to be about $270 million in capital and projecting, probably north of $1 billion in total cost once you include the operations and maintenance over the next 30 years. So very significant investments being required. And so to that end, we really wanted to understand that the technologies we'd be deploying well, test them out. Because of that scale, if you can find something that performs better, you can really realize those savings to our retail agency partners and to the public and their customers. So we started a pilot program kind of in parallel with the initial design of the wellhead treatment systems, testing granular activated carbon, ion exchange resins, and then a couple sort of emerging technologies in absorption referred to as either novel sorbents or alternative absorbents that are engineered to be somewhat more selective for PFAS. And so we've had a good first phase of that really informed our design and construction of the initial systems, identifying suitable products that would have a long life, but also a reasonable cost, and use those to make recommendations for the initial systems. But then, Tom, we've continued that program into subsequent phases, perhaps scaled down slightly because there are more, PFAS selective or PFAS design ion exchange resins and also these novel sorbents appearing on the market that we wanted to retain ability to screen and test such that they could be used as a replacement product in the treatment vessels that are being constructed at each of these sites. So we envision long term having something of an ongoing program looking at new products as they come out. Just because our operating costs are so dependent on how long these absorptive media last.
That's really interesting, isn't it? Because actually there's been more innovation into the market, but you've been ahead of the curve with your kind of pilot program. So actually new solutions have come onto the market that you can then kind of put into play for the testing as you're moving forward. That's a really interesting kind of dynamic. Mohammed, then from your side, where do you sort of see from the kind of the solution point of view and the technology any further innovation coming on?
Yeah, definitely. We are aware of the limitation of the existing technologies. Everyone knows that, and there is heavy focus on identifying, as Jason mentioned, just like we are also on the lookout for what is coming, what has potential, what has like long lifetime and effectiveness, high effectiveness. This is part of my role here. But at the same time, we identify impacted communities. We have that infrastructure law that was released recently to identify impacted communities and try to help them. So there is, I think you put it in the perfect way, just like we have like a spinning wheel and you just try to adapt with anything that comes in. But we have now activated carbon that it is available that can be used on a large scale. In the meantime, we don't envision at all that there is like a silver bullet or like one size fits all solution. It will need to be taken as a case by case scenario where you identify sources and you identify concentrations and take it from there to design a suitable and cost-effective treatment train to remediate PFAS contamination in community or site that you have.
Mm-hmm. So a combination of potentially existing solutions on the market, but also new solutions that are being released as well. Roberta, can you maybe comment on that then from the treatment point of view in KWR's expertise?
Yes, certainly. Of course, we also started looking at the common treatment procedures that we apply, like activated carbon or reverse osmosis. They can be effective, but activated carbon in general is less effective than we would want it to be. For example, if you use granular activated carbon, I can say that the reactivation frequency should be about a factor 4 higher than what is applied in general now. So that would mean a lot of logistics, a lot of extra costs, maybe extra carbon filters. So that will cost a lot of money and cause a lot of trouble to get it implemented. On the other hand, we can use reverse osmosis, but in that case, the recovery of such a process is about 80%. So that means that 20% of the volume that you are treating is left as a concentrate with a 5 times concentrated concentration of PFAS and other contaminants. What are we going to do with that? So at the moment, our research is focusing on improved adsorbents. Is it possible to improve the characteristics of activated carbon, or can we use other types of adsorbents? There are all kinds of new types being developed at the moment. And also looking how can we deal with the concentrate, and is it possible to really degrade the PFAS, or can we only remove it? Because if we only remove it, then it will get somehow again into the environment, and the whole cycle will start all over again.
So I guess by the very name being forever chemicals, if you're with that 20% of concentrate, if that's just being moved elsewhere, then you're just shifting the problem as opposed to dealing with it at the source.
Well, if we somewhere in Europe take it out of the river, concentrate it a factor 5 and discharge it again on the river, then the next drinking water company will have the same problem or even an increased problem. And that's also part why, for example, the Dutch drinking water companies are stressing the fact that something should be done about the use and production of PFAS. They prefer PFAS to be abandoned, that we have alternative compounds for those, and preferably not similar regrettable substitutes, as they are called. What we have seen in the past was that when PFOS and PFOA were thought not as suitable anymore, some companies changed to smaller types of PFAS. But in fact, these are much more difficult to remove than the larger PFAS. So in that case, the problem was only increased. And that's something that we really should prevent to happen.
Yeah, I guess because a lot of the discussions are around removing PFAS from the environment, from the water. And obviously, water companies are at the end of that line where the PFAS is already into the environment. So actually, there needs to be a stop on forever chemicals getting into the environment in the first place, right? But that's typically a conversation and movement and regulatory change and environmental enforcement beyond the water sector. It's industry, it's companies using firefighting foam, it's all of that. And there's a lot of work going on in that respect. But I think what you said, Roberta, around kind of the concentrate is really interesting. Can you, Mohammed and Jason, maybe comment on that from the work, what you've seen in terms of membranes of one solution, but actually there's still a kind of concentrate of PFAS remaining that has to be looked at? Mohammed, if you want to go first on that.
It's an ongoing project that I'm having here. It's because Roberta put it in the best words. It's we are not contributing to make a mass balance of PFAS in the environment. We want to get rid of it. But as I explained, it's challenging, and we are designing a treatment train. So we envision that concentrated waste would require something like as Jason mentioned about innovative or novel adsorbents, that they are more selective, they can withstand these kind of harsh conditions. And you take these and deal with the side waste from it, like you regenerate it and you have a more concentrated waste where you can handle it and destroy it. So it's a work in progress, but it is what it is. This is how the situation we are facing. The things that they have high effectiveness in separation, they have their own challenges about the side waste streams that they get generated from, and it's I think I'm being redundant, but it's just like we don't envision a silver bullet. Each scenario will be just treated separately based on the available technology that you would have. Just like one thought that came to me is about even activated carbon is now a challenge in a different perspective about supply chain. Like, do we have enough carbon that actually can contribute to treat the water? So it's a multi-scale, multi-level kind of complex problem. But the good news is like compared to 10 years ago, we are way ahead. We have a lot of understanding about like separation. We have a lot of advancement in even the analytical world where we can measure very, very tiny, small concentrations of these contaminants. So there is a light at the end of the tunnel, and hopefully we can reach it soon.
I guess you're right. I mean, if you're looking at over 4,000 different PFAS chemicals, actually the technology has evolved to detect and analyze and find that way more than what it was, 10, 15 years ago. So that is an advantage as part of, and a tool needed as part of this toolkit. But Jason, can you maybe comment then on the concentrate and the work and any results that you can share from OCWD?
Yeah, we haven't delved into that area of applied research yet, Tom, but it's kind of on our list as something to keep an eye on. I would agree with Mohammed. I would think the handful of cases I've heard that folks that are treating concentrate, they're usually using a conventional technology, right? They're taking that concentrate to a GAC system or an ion exchange system, simply because I think it's easier to dispose of it in that sort of more solid phase than the liquid phase once it's been separated. So that's sort of I would term that more of a stopgap solution now. I'm hopeful that some of the research going on at places like Department of Defense in the U.S. and its analogs around the world, who are having to deal with high concentrations of PFAS at military facilities that have had to use the aqueous film forming foams through training, other events. Many of those sites have very high concentrations of PFAS there that those sites are dealing with in a remediation context, and I'm maybe cautiously optimistic that the work being done there, dealing with that type of mass, and really looking at destructive technologies, things like electrochemical oxidation, perhaps in the right context, something like supercritical oxidation. Mm-hmm. I'm hopeful that the investments that those agencies are making into those scenarios will have application kind of down the line to more, municipal scale types of concentrates, be they from reverse osmosis, be they a regenerate from an ion exchange resin that, maybe to try to get away from the current use of single use or single pass resins. I'm hopeful those investments made at the federal level will yield some fruit in the municipal scale as well.
So long as that knowledge is transferred across between, right? Finally, then, because we're at the 30-minute mark and we want to sort of wrap up. Roberta, the phrase Jason used there was cautiously optimistic. Would you share the same sort of view when it comes to PFAS and water? Are you cautiously optimistic?
Yes, I think so. There's a lot of research being done at the moment. New materials, new technologies are being developed, but it's more cautiously than optimistic, I think, because the challenges are still very large. And indeed, as Jason was saying, at the higher concentration, it is also better possible to treat PFAS. But if you're looking at drinking water, in Europe at least, the concentrations are very, very low. And that is an extra challenge to remove PFAS from the water, because other compounds like natural organic matter, for example, that's present in concentration of milligrams per liter, whereas the PFAS are present in nanograms per liter. And so there's a lot of competition occurring. And I'm cautiously optimistic. I think we will find a solution, but it will take a lot of effort, I'm afraid.
A lot more effort, a lot more research, a lot more investment. And I think that the three of your viewpoints here at the table are going to be essential. And I'm glad that we could actually bring this together. But Mohammed, finally then to conclude, cautiously optimistic from your side, from your point of view?
Yeah, I am sharing with my colleagues here the same vision. But I'm also very happy with the activities that happening on the federal level. I mean, I'm actually in the ORD, so the regulations and others, they happen in another office, and we get surprised just like as you. But what is very intriguing now is just like, how can you upgrade treatment facilities without such push from high up in terms of the chain there? So I see a lot of improvements in the short and long term coming in treatment facilities to meet whatever regulations that come. And the thing about PFAS in terms of also the research in general, something like destruction, it is very hard to destroy. So if research at some point find a solution for PFAS, this is what I always say, just like if you can destroy PFAS, this means like you're destroying everything in the background as well, because it's very hard. So yeah, I'm very optimistic and hopeful that hopefully in the next like maybe 5 years or 10 years, we will be in a much better situation than now.
Absolutely. Well, there's certainly more food for thought. And this is, I mean, Jason, we've had conversations over the years on this, and I think there's something that we need to keep coming back to, is particularly as you mentioned, Mohammed, with the concentration and limits coming out from the EPA and hopefully the first quarter of 2023. So thank you all for your time. Jason again from OCWD, Roberta from KWR, and Mohammed from the research office, the EPA. Great short discussion for Q Talks. Stay tuned for the next edition of the Q Talks powered by KTM. That's going to look at the water workforce challenges. So the upcoming not planned, but a silver tsunami with very experienced senior water operators retiring, and actually the potential knowledge gap. And we're going to be digging into that in a bit more detail. So thanks for tuning in. Thanks for watching for this Q Talk. We hope you've enjoyed the discussion on PFAS. And stay tuned for the next one.